We wouldn't want to get too far without understanding what we're talking about when we say the word network. Well, we're certainly talking about a computer network. And this is rarely something that could be defined as simple. Real-world networks are often very complicated, very involved, and we're going to see that as we delve into this Cisco world that we're embarking on. And when we're looking here, we could first play off of what we see in our home office. What do you see in your home office? We see things like broadband routers, DSL cable, internet connectivity, often a wireless access point that allows us to use our Wi-Fi, which is great. And we connect up to this thing called the internet, which is a very large series of connections that are facilitated by routers, many players on the internet, no surprises there. But we're in a Cisco class, so we're not so concerned about what happens in the home office. We have to be mindful. We have to be educated on what happens in the home office. But when Raymond began this course and our definition of the course goal, he talked about small to medium size network. And so when I hear small to medium size network, I start to think of what happens in the branch office and the headquarters. Now, these things can exceed the medium scale that we had mentioned. But Raymond, what sorts of things might we see in a branch office and in a headquarters?
Well, in our branch offices and our headquarters, we're going to find switches. We're going to find multiple switches. We're going to find switches connecting up to our end stations. We'll find routers connecting us up out to the internet. Why? Because they have those serial connections that we need, but they also have the Ethernet connections that connect downstream to those multi-layer switches. So we find a lot of those components, those routers, those switches. We'll find PCs, printers, servers, and a whole bunch of different things that we use inside of that network for communications. So really, when we get to headquarters, we're just growing that at a larger scale. We're going to have many, many, many more switches and many, many more routers. We're even going to have data centers, Dan, so that way there we can store all of our information and our resources in a central location for users to access.
And the first time you see this, you start to go, holy smokes, that's a pretty complicated network. But in fact, Cisco reduces those complexities for us by giving us models to work with. So later in your journey, you're going to learn about things like the access and distribution and core layers. And so when you see this now, you're going to go, oh, that's just the enterprise composite network model. That's the typical 3-layer Cisco network model that is wrapped together for a campus area network over there in the headquarters. And you don't even see all the individual links anymore. We also have mobile users that are going to get connectivity. This is where we might have VPN options available to us, so those mobile users can have that same kind of functionality that they would have if they were in a branch office or the headquarters, but all the while being in a remote location, maybe a hotel, a coffee shop, in an airport, and still being able to access the file servers, their email, and things of that nature.
So let's dive a little deeper here and take a look at some of these physical components we'll actually find inside of our network. We're going to have end stations. We have our PCs, we have our laptops, we have different desktop computers, we'll even find tablets and phones and a whole bunch of different things. We'll even have printers connected up to the actual network. Gone are the days where we find people with the printers right on their desk beside them. No, we share printers in our organizations. But all of these devices need something that actually connect them up to the actual network. We're going to need a network interface card that's going to provide that connectivity. And then that network interface card needs some type of cable if we're connecting up physically to the network. Or if we're using wireless, it's going to need an antenna to connect to the wireless network. And then what are we connecting up to? Well, we can connect up to switches physically, or if we are using wireless access points. But our switches, as we talked about here, we have all these different ports that are going to give all these different end stations connectivity together. So they are a central hub of connectivity for all these devices so they can communicate with each other.
Now, Raymond, we saw earlier that there were two different switch icons. So I want to challenge the group here. What kind of switch is that? Is it the multi-layer switch variety, or is it the work group switch variety? And notice now, we're not even prefacing it. It's assumed. If we say this word switch, Raymond, what kind of switch is that?
That is our work group switch, Dan. This is that switch that provides connectivity to those end stations. And then from that switch, look at that, we got another Ethernet cable here in this particular topology connecting up to our router. And notice what that router is doing. It's connecting up two different areas of our network. We've got the network on the left-hand side going down to the switch, and we got the network on the right-hand side going down to another switch. And we'll talk about this in more detail throughout this course, why we organize our network this way and how we can actually set things up. But Dan, I'm looking at this router. Is that the only thing we could have there?
Ooh. Actually, let's challenge you folks too. We want routing services. So we need something, as we'll discuss later, that would be capable of operating at layer 3 of the OSI model. So what could that also be? It could be a multi-layer switch. Okay, multi-layer switches and routers, at least in terms of providing LAN connectivity and routing services, they are interchangeable. But Raymond, I'm looking at this, and I know what folks out there in the audience are thinking to themselves. We've got this hockey puck. You know, hockey's great. This cylinder or this square. We got to show them what this stuff looks like, right? We got to give them a good visual here.
And definitely, Dan, that's what we need to do, because on our network diagrams, we see this. But what do they actually look like in the real world? So let's first look at an actual switch here together.
All right, so this device that we're looking at is the classic switch that we'll be focused on. And when we learn about switches in general, please understand that although we might be speaking about the 2960 switch, when we learn about this switch, we learn about all catalyst switch models. Catalyst switches, well, the word catalyst is there for Cisco's campus area network switch devices focused on Ethernet connectivity and Ethernet switching. There are other switches that Cisco produces, such as the Nexus product line. The Nexus is more focused on the data center and providing not just Ethernet connectivity, but also storage area network connectivity. But we wouldn't use those in the sorts of environments that we're talking about here. We're going to use catalyst switches. And this one is the best device that we can get exposure to first, because it really does teach us about the fundamentals of what it means to be a layer 2 switch. And Raymond mentioned, we're going to have a large array of ports on any switch. Large might be 4 for our home office, but here we can really see a 24 port switch. 24 ports, but if you look, there's actually, on the front of this chassis, there's actually 26. There's 2 that are dangling over there on the right-hand side. And let me tell you a little bit about those. Those are normally higher speed ports, those 2 dangling on the right-hand side. Whereas the left ports might be fast Ethernet, which are 100 megabits per second. So the 2 ports that are individual, 1 gigabit per second. Then the other 24, a tenth that speed at 100 megabits per second. So Raymond, what would I use the 100 megabit per second ports, what we would call fast Ethernet ports, what would they connect up to?
Those fast Ethernet ports would be utilized to connect our end stations up to the network. Whereas those 2 dangling ports that we see on the end there that are gigabit Ethernet ports, we'd use those for uplinks, connecting us up to maybe a multi-layer switch or a router.
So that would be the Ethernet connectivity. I got a problem though. I don't see any power. I don't see how power is going to get to this chassis. So let's rotate this device around so that we're looking at Not, the front end of that chassis is really the business end. But rotate it around so we can see, okay, well, we've got some power over there on the right-hand side of the rear of the chassis. And that looks like just a regular computer power connection, and it is. And there might be some other connections that we might use, such as what we see on the left-hand side, console. Raymond, console, that looks like the same kind of port that we saw on the front of the chassis where we had Ethernet. Is that console connection an Ethernet port?
Well, the port may look familiar and it may look similar, but it has a completely different purpose. This console port is utilized for us to access our switch right out of the box. We're going to need a special cable that we'll talk about later to connect into this port, so that way there we can gain access to this device so we can actually start configuring it. So no, it's although it's using the same type of connector, it's actually a serial link that we are connecting up here as opposed to an Ethernet link.
So we gave you a look into what a typical catalyst switch looks like, and actually a specific one as well. The 2960 is a really good representation of a layer 2 switch, but we also have to think about the routers that we are going to get exposure to. And here we're looking at the router line that we care most deeply about in this course. Now, less so than on switches, we get to be independent about router modules for the most part. Although we might from time to time show you things that are specific to the 2900 series Cisco router chassis, which is actually the right kind of chassis to talk about in this course, and we'll see why. What we learn about could also apply to 2800s, 3600s, 3700s, 7200s, 7600s, 2500s, 2600s. The list goes on and on. But Raymond, what's going on here with this 2900?
Well, Dan, I notice a significant difference right off the bat with this router than with my switch. I'm looking at the front of the router right now, and what do I see? I see a whole bunch of vents. I assume those vents there are to exhaust hot air out of this router, but I see a power plug. Wait. If I think about my switch, we had all these ports on the front of the switch and no power. The power is on the back, but our router here is significantly different. The front, we've got our power connector, and we've got this really nice fancy bezel to look at. There's really not much else going on the front of our actual router. But Dan, if we go around to the back of the router, this is where we start to see a lot of differences between the switch and the actual router, don't we?
Yeah, and so make sure you're looking at the rear side of this, and let's talk you through some of the basics, okay? I see some gigabit ports on the upper right-hand side of the chassis, and so I can see things like GE 00, 01, 02. These are interfaces that were fixed with the chassis. They came with the chassis. But then you can look and you can see I've got a console port, just like a switch. But wait a minute, Raymond. I don't remember this thing, the aux port, being on the switch. I remember a console. It looked like this. What's aux?
Well, aux gives us the ability to connect a modem up to our router. Yeah, I said modem, folks. Don't let that scare you. Why might I want a modem connected to my router? Well, maybe I want to remotely access it so I can administer it. Let's say I can't get to it any other way, and I'm in a remote location. I got to fix it. I could call my router, and I could make a connection through this aux port and gain connectivity so I could work on it. We don't have that with our switches, but we do have that with our routers.
I also see a USB port. We see ISDN ports, ADSL. So this right here, ISDN, would be to connect up to a public switch telephone network with a digital kind of connection. And ADSL. Wow, so this could actually function as a termination device for broadband internet with asymmetric DSL. But some kind of connection that we did not see and should not expect to see is what we see under WIC Module 1. So look sort of to the center top of this chassis, and you'll see these two serial connections. These are smart serial ports. And smart doesn't actually indicate that it has some level of intelligence, but it's a more modern style of serial connection than they originally came out with. So when we're interfacing with a wide area network, we're going to use what we find under WIC 1, which would be serial 0 and serial 1, and understand that this is modular. This chassis is modular. So if I didn't want the serial ports here, I could swap out maybe some more DSL ports, some gigabit ports. And that's a really great thing about this, is they are not fixed ports. They've got the ability for us to take out a module and add new functionality, new connectivity options whenever we need to. And this chassis actually is extraordinarily robust, and it can do a great many things beyond what we'll even see in our CCNA and CCNP journeys, because it's quite capable of doing things that are involved in wireless, IP telephony. So we're going to just scratch the surface of what a 2911 could do, but it's the surface stuff that matters to almost every organization out there.
So Dan, in this course, we're going to be focusing on our Ethernet connections, such as fast Ethernet and gigabit Ethernet, connecting down to our switches, and then our actual serial interfaces that we see on WIC 1 connecting us up to the wide area network and possibly the internet as well. So that's going to be our main focus in this particular course when it comes to our routers.
We did already see some example networks, and we've gotten some exposure already about the complexity of networks and the basic visuals that we would use to describe them. And when we are interpreting a network diagram, it's good to understand some basics about it. Raymond has mentioned serial interfaces. When we write the interface and place the name of that interface in our topology, we're likely to just label that S or SE. So one of the two, S or SE. And so we shorten this. You might wonder, why are we shortening it? Well, we're going to see that we can shorten the interface name even inside of the command line for the chassis. We've also seen gigabit interfaces. Now, on the 2900 that we looked at, the router, we saw that the abbreviation for gigabit Ethernet was GE, for gigabit, and the E for Ethernet. You'll also see it GI. Raymond, why is there a discrepancy between how we might write a gigabit interface in a network topology? And I would say that either is perfectly valid.
Well, typical naming convention, Dan, is to use the first two letters we see, GI. But I mean, sometimes we end up seeing some differences. We'll see GE because gigabit Ethernet, G from gigabit, E for Ethernet. But what we usually see on in our iOS, when we'll dive into it later, we'll usually see GI for the first two letters, just like we see FA for fast Ethernet.
TE is also out there. You might not have a chassis that supports TE yet, but that's 10 gigabit Ethernet. And so these are the kinds of connections that we're going to, as Raymond said, we're going to focus on. There might be ISDN connections out there in the wild. We don't see too many of them, and we're not focused on them in this course. We might see ADSL out there in the wild. We're not focused on them in this course. These are the core interface building blocks that we're going to see on both the router and switch chassis.
I don't want to spend a whole lot of time on this page. We're talking about the impact of user applications on the network. So what we really want to get out of this is understanding that there's different ways that devices can communicate with each other. We could have batch applications talking back and forth, FTP, TFTP transfers, different types of updates. Do we really have any type of human interaction here, Dan, in this case?
No, but it's a great thing. If we're doing like a backup of a file server, this is a big deal for us. But I don't expect it to be something where somebody is constantly monitoring it and doing something with it. We just let it run. Then there's things like interactive applications. The first thing that comes to my mind when I hear interactive applications is I think SQL Server databases or databases in general. So you're running some query against it, doing something with that database, and we have a human to machine interaction. But Raymond, I don't expect real-time communication with the database. If I do something, it's going to do some communication out there to the database. It's going to do its job. It's going to run its query, perhaps. And then maybe within a second, I'll get a response. But it's not super, super, super quick. How is that different than real time?
Well, in that case, bandwidth is important, but it's not critical. When it comes to real time, bandwidth is important, and it is critical. Response times are critical. There's a complete difference in interaction here. With real-time applications, we have human-to-human interaction. Think about phone conversations. Think about video, teleconferencing solutions that are out there. So end-to-end latency is really, really important. And designing our networks and making sure we implement the correct features and services to allow for these different type of applications to all be running at the same time is really, really critical and important for our network success.